calculator in a few minutes, because I was teaching stats in another class, and I think my settings are messed up too. So it's kind of annoying. Anyway, the sequence function actually works on the home screen, so I can show you that later too. I'll do it all in one shot. It's just once I deleted that video, I knew all hope of salvaging that was lost. But for something like these examples here, finding the domain of sequence, remember the idea is that it's a default to the positive integers. All right, so once you have that in mind, the only thing that you're looking to do is restrict those positive integers, if applicable, right? So in the case of number one, it's an even root, so I can't have a negative under the radical. So I need n minus 4 to be greater than or equal to 0. All right, in which case, if I solve, I get n greater than or equal to 4. All right, so that's my restriction, and it's a pretty simple restriction. Bearing in mind that there's nothing wrong with having a negative under an odd root, right? So if it's a cube root, fifth root, whatever, you could have a negative under the radical, and there's no problem. It's only the even roots, right? So what I would state here is my domain is that n belongs to the set of positive integers. Now you could use the colon for the such that, or you could use a vertical line. I like the vertical. I go back and forth, vertical line or the colon. All right. The vertical line is kind of like a little partition mentally for me, so I kind of like that one a little bit more. Such that n is greater than or equal to 4. And, just do the best you can with the squiggly brackets. But this is set notation, and part of the notation is the squiggly brackets. So it's like, do we have to include those? Yeah. Do you have to do them well? No. Just make sure that they don't look like regular parentheses or regular square brackets, and you're fine. All right? So if you're going to make some crappy looking squiggles, that's fine. Nobody's going to lose any sleep over it. All right? It's when you just neglect it, that's where you run into trouble. All right. Now, in terms of the first 4 values of the sequence, well, the domain is a key ingredient here, because if I didn't identify that my domain, bless you, starts at 4, then I might try to put a value of 1 in for n. But the first value of my sequence here is going to be a sub 4, which is going to give me a result of 0. Then a sub 5, which is going to give me a result of 1. A sub 6, which is going to give me a result of 4th root of 2, and a sub 7, which is going to give me a result of 4th root of 3. All right. So did I actually need to state the domain in order to make that realization? No, but it didn't hurt. In number 2, slightly different situation. Yeah, there's a restriction to this function if it were a real valued function. I might say 3n minus 2. Well, I don't want that to be equal to 0, because then it's undefined. If it's undefined, that would be bad news, regardless of what topic we're working on. So n can't be equal to 2/3. But n couldn't be equal to 2/3 anyway. All right, so my domain here is n belongs to the set of positive integers. All right, because 2/3 wasn't a positive integer to begin with. Now, if you wrote such that n cannot be equal to 2/3, is it wrong? No. It's irrelevant. I'm concerned that you maybe don't fully understand the concept, but it's not wrong because you're telling me something that it can't be. All right? I mean, you could also tell me that n cannot be a negative 27. I know, it can't be, because it's got to be in the set of positive integers. It's irrelevant, it's not incorrect if you include it, but obviously something you want to stay away from. All right? The first 4 values. So for this one, you might want to go to the calculator. All right, for now we're living in function mode because I haven't effectively taught the sequence mode, parametric and sequence modes yet. So you just put it into Y1, go into your table, and only get the integer values, positive integer values. So we'd be looking at a sub 1, 2, 3, and 4. So 5, 3/2, 4/5, and 9/13. All right. Number 3 is a very intimidating looking one, but it's no more difficult than the previous one. So I'm going to put a nice juicy star on that one, and also number 4. Our default is the positive set of integers. So I'm looking at all this crazy business here, and really my eye is only drawn to this one piece of information right there. All right. And so if this is going to exist, n minus 6 cannot be equal to 0, which means n cannot be equal to 6. All right. So when I'm stating my domain, really, just like I said yesterday, our default is the set of positive integers. N belongs to the set of positive integers. But then we establish any conditions that might be in place. All right. We don't have to state every possible thing it could be. We want to state any exceptions to the rule. All right. So n cannot be equal to 6. Now, they're asking us to list out the first 4 terms of the sequence. All right. So it turns out that n equals 6 is going to be irrelevant anyway. But if I had to list out more than 4 terms, 5, 6, 10, 20 terms, I could run into a problem in that my sequence would actually skip a value. All right. So just got to do some crunching here. Now you could type this in as a function. We talked about this yesterday. I realized what happened. Let me just write this on the board real quick. It's a -1. When I was showing you the sequence approach, I got my wires crossed completely. I put you in parametric mode when I meant to put you in the stat editor. So, because I knew I was doing both at some point, I just tried merging the concepts together. So let me show you what I had intended on showing you yesterday, which is kind of a nifty approach for getting some numerical values. I gotta slum it and use this calculator. I put my other calculator on the charger at the high school. You know where it is right now? On the charger at the high school, exactly. All right, so 0.6, I just write them in here now. Negative 1.75, 3.6 repeated, and negative 7.5. All right, something to keep in mind. You'll notice that the signs are alternating between positive and negative. This is what we call an alternating sequence. All right, so all right, so if I had to write a rule to represent a sequence of values, and I knew that they were alternating between positive and negative, what I would do is I would incorporate a -1 to a variable power, right? Because depending on where you are in the sequence, that would give us either a positive or negative result. Now, we didn't do these numbers, or we didn't figure out these numbers by hand, so you may look at this and say, well, the first entry, if I plug in a 1 for n, well, that would give me a negative number, but that's not really considering what this ratio here gives us. So in order for the final result to be positive, my suspicion, strong suspicion, would be that this ratio here is itself negative, and then when multiplied by the negative gives you a positive. Whereas if I plug in a 2 here, the result would be positive negative multiplied by a positive, giving a negative, and so on. All right. So just something to keep in mind. This -1 part, that's what leads us to this magical thing called the alternating sequence. All right. Later on, we're going to talk about something called an alternating series test. So when we talk about infinite series, we're going to be building off of this concept, trying to find sums, right, in the infinite sense. So, you know, it's not a one-off, basically. So for number 4, domain, very easy. There's no bad value for n here, right? So n would belong to the set of positive integers. And then the first 4 values, a sub 1, 2, 3, and 4. This is not a situation where I would consider going to a calculator, because the only thing that varies is the exponent of the denominator. So I would just write 3 over 10, 3 over 100, 3 over 10 squared, 3 over 1,000, 3 over 10,000. All right. This is one of those situations I was talking about before where I think it would probably take you more time to type it into the calculator than it would to actually do it by hand.